इंटरनेट भी इतना अच्छा नहीं चल रहा. Good morning, everybody. My name is Ferhan Mazher, and today is 23rd of October 2020. The day is Friday. Right now, I'm with the 10th Cambridge class, and today's purpose is to revise the topic of heat, because we are going to have an assessment on I think 22nd. So we will revise the concepts of the heat. So the first topic which we are going to, there are 4 chapters on the topic of heat, and the first one is the transfer of the thermal energy, and I have taken this from another website. Okay, savemyexam.co.uk. I have taken this worksheet from there. Okay, so on your screen, the question number 1 is showing. So it says, which statement about thermal radiation is correct? In a vacuum, thermal radiation travels at the speed of light. Thermal radiation is a longitudinal wave. That's wrong. The thermal radiation is a transverse wave. Thermal radiation travels as an ultraviolet wave. That's wrong. Thermal energy travels as infrared waves or rays. White surfaces are better emitter of thermal radiation than black surfaces. That's wrong. The black surfaces are the better emitter of the thermal radiation. The first one, the first choice, in a vacuum, thermal radiation travels at the speed of light. That is the right option. So for question number 1, right option is A. Do you understand?
Yes, sir.
Okay, the next one. Question number 2 is on your screen. In a vacuum, thermal radiation travels at the speed of light. That's true. It's a fact. You have not studied yet that chapter.
So thermal radiations तो travel करती ही नहीं है vacuum में.
ये कब पढ़ा आपने? Thermal radiation is in the form of infrared rays, and they travel with the speed of light in the vacuum.
Okay, sir. ठीक है, समझ आ गई.
They are actually the light itself. You have not studied that chapter yet, electromagnetic spectrum. We will study after the sound, the chapter of sound. Then this thing will be very, very clear to you. Okay. A slice of bread is placed under a red-hot electric grill to make toast. How does heat energy reach the bread? You see, between the grill and the slice of bread, the slice of bread is under the grill. So, between the grill and the slice of bread, there is air, and air is a bad conductor of heat. So, conduction, I don't think that's involved. The second method of transfer of heat is convection. So by convection, the heat always travels upward. So because the grill is above the bread, so the heat will not come downward towards the bread. So convection can also not be the reason. The last and the third method of transfer of heat is by radiation. Radiation spreads out in all directions, and it do not require medium, and even if medium is present, it can pass through the medium. So I think that D is the answer, radiation only. I think that D is the option, radiation only. What you said?
Convection से क्यों नहीं?
With the convection, the heat always moves upward. The bread is below the grill, so the heat is not coming downward by the convection. Understand? So
Yes,
D
sir.
is the option. solid bar is heated at one end. How is the thermal energy transferred to the other end of the bar? It's a solid bar. In the solids, the heat is transferred by conduction. The method of conduction or the how the takes place, the molecules they start vibrating vigorously, and they due to the vigorous vibration, the amplitude of their vibration increases. So they make their neighbors vibrate vigorously, and the amplitude of their neighbor vibration, the amplitude of the vibration of their neighbors also increases. So by the vibration of the molecules, the heat is transferred from the hot end to the cold end. So how is thermal energy transferred to the other end of the bar? The A option is heated molecules move along the bar, carrying energy to the other end. That is not possible in the solid, because in the solid, the molecules are fixed in a location. Heated molecules move along the bar, giving energy to the other along the bar. That is also wrong. They do not move along. See, heated molecules stay completely still but give energy to the other molecules. That's wrong. They do not stay completely still. They do not move around, but they vibrate. D option is heated molecules vibrate more rapidly and pass energy to the other molecules. That is true. So the best option is D. Question number 3, the best option is D. Do you understand?
Yes, sir.
Okay. The tube inside solar heating panels use the sun radiation to warm water. Why are the tubes painted black? Because black is a very good absorber of the infrared radiation. If black surfaces absorb radiation well, that's true. Black surfaces conduct heat well, that's wrong. Black surfaces emit radiation well, that is true, but here it's absorbing the radiation. Black surfaces reflect radiation well, that is also wrong. Because it's absorbing the heat from the side. So here we will use that option in which it says that the black surfaces are good absorber of radiation. So the choice is A. Question number 4, the choice is A. Do you understand?
Yes, sir.
Yes, sir.
Okay. A copper rod is heated at one end. Which statement describes how heat transfer occurs in the copper? Copper is a solid. And in the solid, the heat transferred from one end of the solid to the other end of the solid is by the process of conduction. Copper is also a metal. It also has free electrons. So conduction happens by the vibration of the molecules of the copper, and also by the, technically we call it free electron diffusion. It means that the free electrons at the hotter end will absorb the thermal energy and they will move to the colder end. The free electrons will go to the colder end and they will transfer the energy there. And you see the copper, which is a solid and is a metal, the conduction happens by 2 methods in it. By the vibration of the molecules and by the free electron diffusion. So look at the choices. Energetic copper molecules move from the cooler end to the hotter end. No, that's wrong. That's totally wrong. Energetic copper molecules move from the hotter end to the cooler end. That is totally wrong. Energetic free electrons move from the cooler end to the hotter end. They do not go from the cooler end to the hotter end. Free electrons move from the hotter end to the cooler end. So D option is energetic free electrons move from the hotter end to the cooler end. That is the right choice. D is the right choice. Question number 5, D is the right choice. Do you understand?
Yes, sir.
Okay, that's good. Let's move to the next question. Question number 6. Which statement about copper explains why it is a better conductor of heat than glass? Because copper is metal and the glass is insulator. The vibration of the molecules will happen in both copper and glass, both. But the copper has free electrons in it. So the diffusion of free electrons can take place. Diffusion of free electrons means that the free electrons on the hotter end will absorb the thermal energy and that they can flow in the copper. The free electrons can flow or they can move from the hotter end to the colder end in the copper. The free electrons are not present in the glass. So that's why the copper is a better conductor of heat as compared to glass. Option A. Atomic vibration is passed onto the neighboring copper atoms quickly. Atoms move through the copper and pass on kinetic energy. That's perfectly wrong. There are density changes within the copper. No, the option is there are free electrons in the copper. The reason that the copper is the better conductor as compared to glass is the D option. There are free electrons. So my dear students, we are on question number 7. The diagram shows a frozen pond with the surface of the ice slowly melting as heat is transferred from the warmer air above it. By which process is heat transferred from the air to the ice? Because we have air which is warmer, its temperature is 5 degrees centigrade, and we have a layer of ice on the surface of the pond. And from how the heat is transferred from the air into the ice is below the air, so the only method possible is radiation. So whatever option has the radiation in it, that can be the answer. So C and D, you can see they are the options, convection and radiation only. C is and the D1 is radiation and conduction only. You see, by convection, the heat always travels upward direction, and so the heat will not go downwards. So air, no doubt, is a bad conductor of heat, but a little bit heat is conducted through the air. So radiation and conduction only. Another very important thing is that in the ice, the heat will be from the outer side of the ice to the inner, the bottom side of the ice. The heat is transferred by conduction. So from the air, the heat is being transferred to the ice. In the air, the heat is transferred by radiation, and in the ice, the heat is traveling by conduction. So D is the right option. Question number 7, D is the right option. I hope that you have understood. It's a very tricky question, that how the heat traveled in air, and I think how the heat traveled in the ice. So heat traveled in air by radiation, and heat traveled in the ice by conduction. So D is the right option. I hope you have understood. Let me reduce the size. A glass beaker contains water. When the center of the base of the beaker is heated, a convection current is set up. So from at the center they are heating, so the convection currents will set up in the water. So here you can see that the water is going up, and on the side the water will be going down. Which statement explains this? The convection currents are set up due to the density changes. Remember that word, density change. The convection, the heat is transferred to the convection currents because of the density changes. Remember these words. A option, the evaporation of water causes water molecules to rise to the surface. Wrong. The expansion of water molecules causes them to rise to the surface. The molecules of the water do not expand. The molecules of the water do not expand. The space between the molecules of the water will increase. C option is the water above the heat source rises because it becomes less dense. Yes, this is the option. The water above the heat source rises because it becomes less dense. That is the answer, man. The water at the side sinks because it becomes dense. That's wrong. So the correct option is C. C is the right option. What do you think?
Yes, sir. C होगा.
Yes, sir.
Okay. The next question on your screen. Two identical metal plates are painted. One matte dull white and the other matte black. These are placed at equal distances from a radiant heater as shown. The heater is turned on for 5 minutes. Which metal plate absorbs more energy and which metal plate emits more energy in this time? You know, the matte black metal plate, it will be absorbing the most energy, and it will be also emitting the most energy. Absorbs more, the black, and emits more, that is also black. So A is the right option. G, do you understand?
Yes, sir.
Okay, so let's move to the next one.
सर ये टोटल हमने कितने करने हैं?
Total. There are, I think, 40 questions in this worksheet. Let me see. There are 35 questions in this worksheet, and this worksheet is about the transfer of heat. Okay. A saucepan is used to heat up some water. Picture.
सर तो अभी सारे 35 करने हैं?
अगर जिंदगी नहीं तो करेंगे.
Okay, sir.
A saucepan is used to heat up some water. How is heat transferred through the aluminum pan and through the plastic handle? Through the aluminum pan, the heat is transferred by conduction. And because aluminum is a metal, and metals, when the conduction happens in metals, that happens due to the vibration or due to the increased or more rigorous vibration of the molecules, plus due to the free electron diffusion. Whereas the plastic handle is an insulator. In the insulator, the heat travels from one end to the other end only because of the vibration of the molecules. Okay? So, heat is transferred through the aluminum pan by A option is the movement of free electrons and the vibration of the atom. That is true. And heat is transferred through the plastic handle by the movement of free electrons and the vibration of molecules. That's wrong. So A cannot be the answer. B option, the movement of free electrons and the vibration of atoms for the aluminum pan. That's right. And for plastic handle, it says the vibration of molecules only. That is true. So B looks the best option. B looks the best option. In the C option, he said the movement of free electrons only. He used the word only. That's why it's wrong. In aluminum pan, the vibration of molecules is also happening. And in the D option, he again used the word the movement of free electrons only for the aluminum pack. So that's why the C and D are wrong. So B is the best option. Do you understand?
Yes, sir.
Okay. Question number 11 is on your screen. A silver cup is filled with boiling water from a kettle. A man touches the outside surface of the cup and finds that it is extremely hot. Why is the surface so hot? Because you see, it's a silver cup. Silver is a metal. And inside the cup, you have put some boiling water. So because silver is a very good conductor of heat, so the water which is boiling and is inside the cup, from it, the thermal energy from the inner surface of the cup will be through the conduction reach the outer of the cup. So when you touch it, it will be extremely hot. So this is happening due to the conduction. Convection, A option is, why is the surface so hot? A option, convection takes place in the boiling water. This is not the reason why the outer surface is so hot. Silver is a good conductor of heat. That is the right option. The exact words which should have been there. And the C, the boiling water gives out latent heat. That's wrong. The shiny surface is a good emitter of infrared radiation. That's perfectly wrong. So B is the best option. Silver is a good conductor of heat. What do you say? Do you understand?
Yes, sir. Yes, sir.
जी सर.
Okay. So let's move to the next. 4 containers are filled with equal volume of water at the same temperature. Container A and B are shaded by a tree. Sunlight falls on a container C and D. From which container does all the water evaporates first? The container evaporation rate will be faster in the container whose surface area is larger, plus the container which is in the direct sunshine. So what do you think is the option?
D.
D.
So D is the right option. D is the right option. Okay. In the D container, the rate of evaporation will be the fastest. Okay. Question number 13 is on your screen. A rod of metal is heated at one end. Which statement best describes the conduction of heat through the metal? Atoms move from the hot end and hit electrons at the cold end. This is the right thing, but not only this. Atoms, sorry. No, sorry. I just made a mistake. Atoms move from the hot end and hit the electrons at the cold end. That's wrong. Atoms do not move in a metal. Atoms vibrate and hit the atoms at the cold end. That is also wrong. C option, free electrons move from the hot end and hit the atoms further along the rod. That is the right option. The D, free electrons vibrate and pass energy to the free electrons further along the rod. That's wrong. The free electrons are not vibrating. They actually move around. So C is the best option. Question number 13, C is the best option. Question number 14. 4 wet towels are hung out to dry as shown. Which towel dries most quickly, sorry. Which towel dries most quickly? So what do you think? Which will dry most quickly?
A.
A, yes. Sunny and the windy conditions. The rate of evaporation will be fastest. So A is the right option. Question number 15 is on your screen. How is heat conducted in a metal? In a metal, by the process of conduction. And conduction is done by two things: vibration of atoms and the movement of free electrons through the matter. So what's the option?
C. C.
C is the best option, by vibration of atoms and movement of electrons through the metal. So C is the best option. Okay, question number 16. A student uses a double-walled glass vessel to contain a hot liquid. What reduces the heat loss by radiation? What can stop the radiation?
A.
Vacuum cannot create, a vacuum cannot stop the radiation. Remember that thing.
B, sir.
What?
No, C.
Painting the surface cube black. Black is a very good emitter of the infrared radiation. So B cannot be the answer, ma'am.
Sir, D.
Painting the surface as silver. That's right. If you paint it silver, the silver is a bad emitter of infrared radiation. So D is the option. What do you say? Do you understand?
Yes, sir.
Yes, sir.
Okay. So next question is on your screen. In hot weather, people use electric fans to keep cool. Why do the fans make them feel cool? Because the fan, they increase the wind speed around you, and by increasing the wind speed, the rate of evaporation becomes faster. So why do they make us feel? They change one
Sir,
form of
C?
energy into another. They cool the air in the room. No, they increase the rate of evaporation from the skin. Yes, that is the right option, man. C is the right option. Do you understand, everybody?
Yes, sir.
Okay. So here comes question number 18 on your screen. Yeah. 4 metal cans are identical except for the color and the texture of their outer surfaces. 100 cubic centimeter of water at 70 degrees centigrade is poured into each pan. Which cools the most rapidly? Which will cool the most rapidly? They have the same amount of water. The temperature of the water is also same. Only the texture and the color is different. The outer texture.
Sir, black and
color.
shiny one.
The black and the dull one. Shiny is not the right. Black and the rough surface. That is the best. Yes, A is the right option. The black and the rough surface will be the best emitter of infrared radiation. So the water in that container will cool the quickest, most rapidly it will cool. So A is the right option, ma'am. On your screen, question number 19. How does heat transfer through a vacuum take place? So by which method the heat travels in the vacuum?
Sir, by radiation only.
Radiation only. D.
D is the right option. When the refrigerator is switched on for the first time, the air surrounding the ice box is cooled. What happens to the density of this air and to its position inside the refrigerator? You see the air here around the ice box, it will get cool. When it will get cool, its molecules will come close to each other. The distance between the molecules will decrease, and those molecules, their density will increase and they will move downward. So what's the option?
C, sir.
The density will increase and the position of the air molecules, they will sink to the bottom. That is the right option. C looks the best option. So for question number 20, C is the right option. The diagrams show 4 identical cans with their outside surfaces painted either dull black or polished silver. Each can contain the same volume of water initially at 80 degrees centigrade. After 5 minutes in a cool room, which can contains the coolest water?
Sir, the dull
See the
black without
can?
lid.
Yes.
Yes, the dull black, because the dull black is a very good emitter of the infrared radiation, and without lid, because when there will be no lid, the evaporation will happen. And evaporation is also a form of loss of thermal energy to the surrounding. So A will be the coolest water after 5 minutes. So A is the option. It decreased too much. The diagrams show 4 cans in a cool room. They are painted as shown. One pair is filled with hot water and left to cool down. The other pair is filled with cold water and placed near infrared heater. The hot water in the black can cools more quickly than the hot water in the white can. The cold water in the black can heats up more quickly than the cold in the white can. Which row shows the reason for this? You know, if the black can has hot water, the black will be good emitter of the infrared radiation as compared to the white can. If the black can has cold water in it, then the black will be a better absorber of the infrared radiation as compared to the white can. So the black is a better emitter of infrared radiation, and black is also a better absorber of the infrared radiation. So better emitter of infrared radiation, that should be black, and better absorber of infrared radiation, that should also be black. Okay. A black will absorb heat or it will emit heat. That depends upon its temperature and the temperature of the surrounding. If the body which is black, its temperature is higher than the surrounding, then the black body will be a very good emitter of infrared radiation. If the temperature of the body which is painted black, is less than the temperature of the surrounding, then it will be a very good absorber of infrared radiation. So the black is the better absorber of infrared radiation, plus the black is also the better emitter of infrared radiation. So the option is A. Do you understand this concept?
Yes, sir.
A. The next question, I'm trying to do it very quickly because, you know, the time is over almost, but we can take 5 minutes more. In a vacuum flask, which methods of heat transfer are prevented by the vacuum? Vacuum can stop what?
Conduction and convection.
Vacuum cannot stop,
C,
vacuum
sir.
cannot stop radiation.
Sir,
Yes,
C.
yes, the vacuum cannot stop radiation, but the vacuum can stop conduction and convection because they both require medium. So the best option is C. Question number 23, the best option is C. ice is taken from a freezer and left in a room, the ice melts and eventually the water reaches room temperature. Which energy transfer takes place? Energy transfer during melting. The energy will be when the ice is melting. The energy is transferred from the surrounding to the ice. That's why the ice is melting. And then the temperature of the melted ice will rise. Even then, the energy is transferred from the room to the water or
Ice.
melted ice. So what's the
So, sir,
option?
C.
In both cases, the heat is transferred from the room to the object. So what's the option?
C.
C.
C is the right option. Okay, do you understand this thing?
Yes, sir.
Yes, sir.
Okay. Next question is question number 25. The diagram shows a simple manometer. Side X is connected to a gas supply. Side Y is open to the atmosphere. What pressure is the length H used to measure? This question is not on the topic of heat. I don't know why this is in that worksheet. But anyway, we can do that. What pressure is the length H used to represent? This tells you the difference between the pressure of the gas and the atmospheric pressure. Okay.
B.
What's the
B.
option?
B.
B, sir. B.
It tells you the difference between the gas pressure R and the atmospheric pressure. B is the right option. Okay. A thermocouple thermometer is made from two wires connected to a voltmeter. Which arrangement gives a reading on the voltmeter, temperature of the voltmeter? The temperature of the voltmeter should be, you see, both junctions. You know, in a
It's
thermocouple,
B.
we have two junctions. So he has shown here a hot junction. So the temperature of the voltmeter should be colder than the hot junction. Hot junction is supposed to have a higher temperature, and the other junction should have lower temperature. So there should be temperature difference. So hot junction is shown here. The temperature of the voltmeter should be less than the hot junction. It should be colder than the hot junction. And I told you when I taught you this topic that in the voltmeter we use two wires, and both the wires are of different material. So the upper wire is a copper wire, so the lower wire should be of a different metal. Okay, so what is the option?
B, sir. B.
B, the temperature of the voltmeter should be colder than the hot junction, and the wire X should be made of iron. So B is the right option. Okay. A double glazed window has two sheets of glass separated by a layer of air. Thermal energy is conducted and convected through the layer of air. The amount of conduction and convection varies with the thickness of the layer of air as shown in the graph. Which thickness of air produces the smallest energy transfer and why? You see, this graph shows, this is the graph for the conduction, and this is the thickness of the air. If the thickness increases, the heat loss by the conduction will continually, it will gradually decrease. And here I have the graph for convection, and you can see as the thickness increases, the thermal energy transfer increases. The energy lost by the process of convection will increase if the thickness of the layer of air increases. So here with the dotted, he has shown that combined effect of both of these. So we are looking for a point where the heat loss is minimum. So
B,
in this
sir.
dotted graph, if you look at here at the where it has the, call it asymptote, where the graph turns, and if you look at the x-axis, the value is 1. So the thickness of the layer should be 1. So B is the option, 1 centimeter, because the total thermal energy transfer is least. So B is the right option. You understand?
Yes,
Yes,
sir.
sir.
Okay. So water at the top, let me decide. Water at the water at the top of a hot water tank is heated and the water becomes hot. No water enters or leaves the tank. Water at the bottom of the tank stays cold for some time. Why is this? You see, if you want to heat the water, the heater should be put at the bottom, because in water the heat is distributed by the convection currents. And by the convection currents, the heat travels in upward direction. So where you put heater here, the convection currents will go up from this point and come down and then go up. So the water which is above this heater will become hot.
So,
But
sir,
the
the
water
answer is
which is
B.
below this heater, that will not get hot. So hot water at the bottom of the tank rises to the top. Water is a poor conductor of heat. That's the reason. Cold water at
Sir,
the top of the
C
tank
होगा ना?
falls to the bottom. The water is the poor conductor of heat, because from the heater, the heat is not reaching downward, because by convection, the heat will go upward. So the other method available was the conduction. But the heat, because we have the water here, water is not a good conductor. So that's why the heat is not coming downward. It will take a lot of time. So C is the best option. Okay?
Yes, sir.
C is the right option. It can be a little tricky. Okay. Question number 29 on your screen. Density changes are responsible for which method of thermal energy transfer? I told you. Remember this word. Density changes. And the method
Conduction?
convection
sir, convection.
only. Convection only. So what's the option?
B.
B is the right option. Yes. B is the right option. Okay. Question 30. The heat from the hot water in a metal radiator passes through the metal and then spreads around the room. What are the main processes by which the heat is transferred through the radiator and okay, my dear students, I am back due to the internet, because the internet all of a sudden disappeared. So our call was stopped and our recording was also stopped. We were on question number 30, I think, but so I'm doubtful that we were on the question 30 or question 29 when the internet stopped. I noticed it stopped when I was on the question 30. So let's start from question number 29. Density changes are responsible for which method of thermal energy transfer? Density changes name is connected with which transfer of heat?
Sir,
Fatma?
convection.
Convection only. Okay, so B is the right option. Question number 29, D is the right option. Question number 30 is on your screen. The heat from the hot water in a metal radiator passes through the metal and then spreads around the room. What are the main processes by which the heat is transferred through the radiator and then spread around the room? Through the metal radiator, conduction will happen, and in the room, because room has air, in the air convection takes place. So what's the option?
B.
Conduction and convection. So B is the right option. Question number 30, B is the right option. Question number 31. The diagram shows a thick copper plate that is very hot. One side is black, the other is shiny. A student places her hands the same distance from each side as shown. Her left hand feels warmer than her right hand. Which statement is the correct conclusion from the experiment? You see, her right hand is on the shiny side, so the shiny is a bad emitter of the heat. The left hand, the heater has the black color on the left side, so the black is a very good emitter of the infrared radiation. So, what could be the option? Which statement is correct conclusion from the experiment? The black side is hotter than the shiny one. The black side radiates more heat. Yes, the black side will be radiating more heat. So that can be the answer. C is the shiny side radiates more heat. That's wrong. And D, the shiny side is cooling down faster than the black side. That is also wrong. So what's the option? What is the option? The right option. I think the B is the right option. The black side radiates more heat. That's why
Yes, sir, B.
the left hand feels warmer than her right hand. Okay? Here we come.
Okay, sir.
Question number 32. On your screen, question number 32. The diagram shows a room seen from above. It is cold outside the room. The room is heated by a small fire in the fireplace. Where is the most heat lost by convection? So it has a chimney in the fireplace. So through the chimney, the convection will be happening. The rest of the room has walls, it has carpet, it has solid wall, the door is closed, the window has glass in it. So where is the most heat being lost? The room has a
Sir,
chimney.
B.
So B is the right option. Through the chimney, the most heat is lost by convection through the chimney. B is the right option. You understand?
Yes, sir.
Yes, sir.
Okay. This was question number 32. Now we are on question number 33. An experiment is carried out as shown in the diagram. So here we have a test tube. In the test tube, we have water. The test tube is little tilted. And on the top side, on the top end, we are boiling the water with the help of the Bunsen burner. We have a metal gauze, and that keeps an ice cube at the bottom, and it's preventing the ice cube from floating and coming on the top. And the ice cube is not melting. The water on the top is boiling, but the ice cube is not melting. The reason is, from here, the heat will go up in the air and the water by convection, but the heat is going upward only. Here, the heat can reach the ice cube, but that can reach if the water is a very good conductor of heat. If the water is a very good conductor of heat. By convection, the heat do not come downward in the water. So the heat could have reached the ice cube by conduction if the water was a good conductor of heat. So the heat is not reaching there, the ice is not melting. The reason is because the water is a bad conductor of heat. So what is the option?
D.
Why does the ice take a long time to melt even though the water at the top of the tube is boiling? So what do you say? What is the option?
D.
D.
B is the right option. Water is a poor conductor of heat. It's a very, very famous concept. Okay, question 34. The diagram shows a vacuum flask and an enlarged view of a section through the flask wall. The main reason for the silvering is to reduce the heat transfer by. What does the silvering will stop? The color silver. What it will stop? Which method of transfer will be stopped by the silver color? Silver color, it cannot stop conduction. It cannot stop convection. The color silver color can only make things, because silver color surface will be a bad emitter of infrared radiation. So it will be affecting the radiation. So what's the option? What do you think? What is the option? Hello?
Sir, conduction only.
The silver color cannot affect the conduction and convection. So rethink.
C.
Think again. Fatma, think again. If I color a surface silver color.
B.
Dua, what you said?
B.
B is the right option. When you color a surface silver, it will become a bad absorber of heat. It will become a bad emitter of heat. So the heat transfer will be reduced. So B is the right option. Here you are supposed to tell us the main reason for the silvering means the color silver, is to reduce heat transfer by. The silver color will reduce the radiation. Okay, Fatma, you understand?
Yes, sir.
Okay, so we are on the last one. A teacher has a large tank of water in which he wants to set up a convection current. Remember this thing. If you want to set up convection currents in a body of water, there are two methods. You can do it by cooling and you can do it by heating. If you want to set up the convection currents by heating, the heating should be done from the bottom. If you want to set up the convection currents by the cooling, then the cooling should be done from the top. So, which of the following arrangements would do this? Setting up a convection current. Cooling at the X, the cooling is always done from the top. Cooling at Y, yes, that can be the answer. Heating at the Y, that's wrong. Heating is always done from the bottom. Heating at Z, that is also wrong. The heating should be done from the bottom. So what is the right choice? What do you say?
B, sir.
B is option to set up convection currents in the body of the water. If you are doing it with the cooling, it should be done from the top. So cooling at Y is the right option. That was question number 35. B is the right option. So, dear students, today we have done this worksheet. This worksheet is about the transfer of thermal energy. These were the MCQs. And I have taken this worksheet from this website, www.savemyexams.co.uk. I have uploaded in your Google Classroom 4 worksheets from this website. And one of them I have done in this video. The rest of the 3 I will also do them I will upload the video in my YouTube channel also. But this is your task to complete these 4. Okay. So that's it for today. And my name is Ferhan Mazher. I was with the 10 Cambridge class. Today is 23rd October 2020. Today is Friday. We were studying Physics 5.5.4. We were working on our MCQ worksheet related with the transfer of thermal energy. So, thank you very much and have a good day and God bless you all.